In this quick intro video, I'm going to give you an overview of the StructureWorks add-on. I'll cover how to install it, and I'll also go over some basic usage. So once you download StructureWorks, you will have a zip file. The first thing to do is go ahead and open up that zip file. All right, and inside this folder, you will see two things: the add-on itself, which is this guy here, and then a license and disclaimer. Have a quick look through that license and disclaimer, make sure that it's compatible with what you plan to use the add-on for. And if you're happy with that, you can go ahead and install the add-on. So StructureWorks is just like any other Blender add-on. You install it the exact same way through the preferences panel. So you'd go to Edit, Preferences, come down to add-ons, and in my case I have it installed naturally, but what you would do is come up here to this little drop down and click, where is it, install from disk. Then navigate to the add-on that I just showed you, the zip file I just showed you, that was in beside the license agreement, and then click it and that will install the add-on for you. Now for me, I already have it installed, so I'll just take a quick look here. So I have several versions installed, but this is the one that you want, StructureWorks. You'll only have one version on your computer. So if I expand this down, you'll see that it's StructureWorks version 0.1.0. Okay, so with that installed, we can go ahead and start using the add-on. So the add-on lives in your N panel. So by hitting N on your keyboard, you can bring up your N panel, and StructureWorks will be one of your tabs along the right hand side here. For me, it's the top tab here. So what I'm going to do is run through the analysis of each of the 4 structures that come with the add-on in the demo structures library. So you've got this library down here at the bottom. If I click on this guy here, it expands and shows 4 different structures, and these are just provided as a way to help you get going using the add-on straight away, just to get a feel for how it works without actually having to model any structures yourself. So let's start off here by selecting everything in the 3D view and hitting X to delete it, so we've got a fresh scene. So let's run through these one by one. The first structure here is the simple 2D truss. Now the analysis of all of these structures follows the exact same procedure. The reason that I'm going to run through each one of them is just to cover some of the nuances around restraint for these structures, because StructureWorks is a 3D add-on in that the analysis is inherently or assumes a 3D structure. So in the case of this guy here, this truss, it is a 2D structure, and so we have to add sufficient restraints in order to restrain it out of plane. So that's the main thing that I want to cover with each of these different structures. Okay, so we've selected the structure here. We can do a couple of different things at this point. In this first panel, in our structure mesh panel, we can either turn the wireframe on or off. We can look at node numbers, we can look at member numbers, we can turn on a mesh representation of the model. So I'm going to go into viewport shading here. So we've got a mesh representation. With that on, we could turn off the wireframe, and we can just see a sort of a nicer representation. We can change the size of the members. Now, important to note here, me changing the size of the members here is purely a visual thing. For the purposes of structural analysis, the cross-section size is governed down in our sections panel, which we'll get to now in a second. So that is just a visual thing. We could turn on a mesh to represent the nodes, and we could increase or decrease the size of that, whatever you want. So let's just put that back to 0.03. We'll turn it off. In fact, we'll turn off the mesh representation and we'll turn back on our wireframe. Okay, so let's get cracking here. The next thing we need to do is add some materials, right? We can add as many materials as we like and then assign those materials to individual members within our structure. So I'm going to start off here by adding a material, and now I need to set the characteristics for that material. So with it selected in the 3D or in the list here, I'm going to come on down and I'm going to give it a name. For me, that's just going to be steel. We need to set a Young's modulus. One of the other things that you need to be aware of with StructureWorks is it assumes you're keeping track of your units. It doesn't do any unit conversion in the background. So for me, I'm sticking with newtons and meters throughout my analysis. So my Young's modulus is going to be 210 gigapascals. So that's going to be 210, and then I can use scientific notation, so I can say 210 E9, and that gets me my Young's modulus. My unit weight, this is going to be steel, so it's going to be 77,000, so 77 E3 newtons per meter cubed. So again, I don't have to input the units, I just have to make sure that I put in numbers that are dimensionally consistent. So with those properties established, I can go ahead and assign that material to all of my elements. So material assignment and cross-section assignment happens in edit mode. We're currently in object mode, so if I hit tab, I'm now in edit mode. Now nothing is selected, now everything is selected. So I want steel to be applied to all of the members. So with all of the members selected, I can just hit assign. We can then deselect all of our members if we want, and then hit select, and we can see that we're selecting all of the members that have this material assigned to them. I could also turn on member numbers, and I can see material 1 assigned to all of my members. Okay, great. So with that done, we can move on to cross sections. I'm going to add a new cross section. In fact, I'll have 2 cross sections. The first one I'll just call tube 1, and I'm going to give that a cross-sectional area of 0.0035. It rounds up to 0.004, but in the background it is 0.0035. Now what I want to do is come back up here actually and turn off material numbers. I want to assign that tube section to my top boom and my bottom boom. So again, I'm in edit mode, so I'm going to go into front view mode, and I'm going to deselect everything and then box select the top and box select the bottom members, and with those members selected I can hit assign, and that assigns that cross section to those members. Now my other members in here, I want those to be assigned section 2. I'm going to come into section 2 here, I'm going to call it tube 2, and let's just give that a smaller cross sectional area, 0.002 will do. And then with that selected in my list here and these members selected in the 3D view, I can hit assign, and now we've assigned that section to those members. And we can confirm that by going ahead and turning on section numbers, and we can see section 1 all across the top and bottom, and all internal members are section 2. Okay, great. So with that established, in fact, let's just turn those off. With that established, we can come on down to our support and restraints. And if you're going to run into trouble or you're experiencing what you think is unexpected behavior, the likelihood is that there is an issue with your restraints. Again, StructureWorks in its current form assumes you know what you're doing essentially, and it won't tell you if you provide insufficient restraints. It will still try and run the structural analysis, and it will just give you crazy results, and it'll be up to you to understand why you're getting those results, and it usually comes from insufficient restraint. Okay, so let's come back into our model. Now, this is a 2D truss model, right? So what I want to do is, let me first deselect all of those members. I'm going to go into node select mode here. So now I want to have full restraint on that node. So in my restraints panel, I'll hit UX, UY, and UZ, and I will add that restraint. Now, that's added in the 3D view here. It's a little bit large, so let's just reduce the scale. And now down here, I want this to be a roller. So I want it restrained in the Z direction, but also in the Y direction, the out of plane direction for this particular structure. But I don't want it restrained in the X direction. So I'll deselect X and hit add restraint, and we can see we've got the right restraint. Now I want everything else that I haven't touched yet to be restrained in the Y direction only. So there are a couple of different ways I could do this. Probably the easiest way is just select these 2 guys, the 2 that I've already worked on, and then come up to select and then invert my selection, and that selects everything else. So with all these guys selected, I'm going to deselect UZ here and just leave UY selected, and then I'm going to add that restraint to all of my selected nodes in the 3D view. Okay, excellent. So now that model is sufficiently restrained, completely restrained out of plane, and it's restrained in a simply supported manner in its plane. So with that done, we can turn off those guys and collapse that down and come on to applied forces. So applied forces, you get the idea at this stage. It is just about setting the force values you want, selecting the nodes in the 3D view, and then adding the force. So let's say I want to come in here and I want to add a minus 10 kilonewtons, so minus 10,000. Now with that selected here, I need to add it to that node, so I'll hit add force. There we go. Let's say I want 5,000 on either side of it. I'll change that to minus 5 E3, and then I will add force, and we get some relative scaling between the force arrows, which is nice. Alright, so forces are added. I could add or include self weight by just clicking that and selecting the axis that the gravity loading is acting in and the direction that it's acting, but I'll leave that off for now. So we can collapse that guy down. Now at this stage I can do a couple of different things. I can either export the model, and what that does is it exports all of the nodal coordinates, all of the member definitions, all of the loading information, cross-section information, etc., into a CSV file. And that's handy if you want to take this model representation and analyze it somewhere else, or bring it somewhere else, or do something else with it. So that's just about setting a path, adding a file name, and then you can, if you want, add a little timestamp on the end of the file name and then hit export. What the timestamp does is it just stops you overriding the previous file that you exported if you did export a previous file. So it's a handy little way of making sure that you don't override old files. So we won't bother doing that for now. I'm going to collapse that down and come straight down to analysis. Now you'll notice that the analysis button, you can't click it right now because we're in edit mode. We want to go into object mode, so hit tab, and now we can analyze the structure. The analysis is done. So we'll collapse that down and just have a quick look through results. This isn't really, the purpose of this video is not really to dig into the results themselves, just to show you how you get results. Now you'll notice here that I don't see any node numbers appearing here. That just means that I need to drag this out a little bit more. You'll also notice that we have rounding, so all of our numbers look like they're zeros here, but if I drag that out a bit more, you can see we are just having some very small nodal displacements basically. Remember, we're operating in meters here. If we wanted to change our units throughout our analysis, we'd start again, and maybe we would input our values in terms of newtons and millimeters, and of course that would change the scale of the results that we're seeing in these lists here. Alright then, so these are our nodal displacements. We can come on down, and the easiest thing to do is just turn on a deflected shape. The deflected shape is scaled to 1 by default. Let's increase that, so 20, let's go with 200, and you get to see what the deflected shape is doing. And of course we can, drag. I find it's kind of useful actually to drag this back and forth for a more complicated structure to get a qualitative sense of what the structure, what way it wants to deflect under the loads. So with that demonstrated, let's come on down and look at, we'll turn off deflected shape, and we'll come on and look at our member forces. So we can visualize the member forces. So if I hit that button there, we get a color map. Now I'm going to come up to the very top again and turn off my wireframe, and we can get a clearer picture of what the member forces are. So if I scroll on down here, we can see that we could increase the scale of the mesh representation here just to make it a little bit easier to see. We could change the color map from red, blue, continuous. Previously it was jet, continuous. Or if we just want to know what members are in compression and what are in tension, and we're not worried about the specific values or the relative values, we can turn on a red, blue binary, and that will tell us what's in compression, what's in tension, and interestingly, which members are zero forces, which is obviously this guy here and this guy down here. All right then, so another thing that we can do, which is helpful, is turn on member force labels, and with that turned on, we can actually go in and take a look at the forces in each of our members. So again, that's kind of handy as well. So if I turn off my visualize forces and turn off member labels, you'll see that you don't see anything. That's just because we've turned off our wireframe up the top, so we got to turn our wireframe back on. Alright, so that is in a nutshell the add-on. We could export our results. The exact same logic as exporting the model applies here. Set a path to where you want the file to go, a file name, add a timestamp or not, and just hit export if you want to use these results in something else. We have a set of UI visibility controls down here, so this just collects all of the different toggles for turning things on and off in the UI, so you can see them here. So you can turn on node numbers from here, or up in the structure mesh panel, you could turn on deflected shape here and change the scale here, or you could do it in the deflection panel. It's just an easy way of collecting everything into one place. We also have a pie menu, so by hitting Alt and W in the 3D view, you bring up a pie menu, which allows you to, again, gets you quick access to your UI controls, and pretty much just repeats what's in the visibility panel here. So to cancel that, I'll just escape to cancel it, and that's pretty much it. Then you're just back down to the demo structure library. So that is how you run an analysis in StructureWorks in this current release. So let's go back up to the top here. I'm going to clear out that structure, which will clear out all of my results. And in fact, I'm going to, over in my outliner here, we can just collapse down templates. We don't need to see that. Those are just template meshes for our force arrows and for our restraints. I'm going to turn the 2D truss off in the 3D view, and let's now run through the analysis. I won't go through it in so much detail, but I'll just run through a very basic analysis for, let's go with the 3D truss, not 3D truss, the arch truss next. So scroll out and there you've got this arch truss. So again, it's pretty straightforward. We can come on and set everything to steel. So I'll go into edit mode. Everything is selected by default. If it wasn't, we'll just hit A to select everything, and then assign steel. Done. For simplicity here, I'm just going to assign everything tube 1. So I'll hit assign. Again, if you want to make sure that you have assigned everything, you can just turn on those labels. The labels can get a little bit difficult to read when your structure starts to get very big and you get a lot of members. And so what you can do is just hit select, and we've selected everything that is tube 1. For example, if I deselect everything, went to tube 2, noting that nothing in our structure has tube 2 assigned, if I hit select, nothing lights up. So that's what this select and deselect are for, really. Just easily allowing you to identify the members in your structure which have a given cross section. Alright, so we've done that. Restraints. Okay, this is where we want to pay some attention. So I'm going to go into vertex select mode because we apply restraints to vertices. I obviously want this guy, well, that obviously wants to be a pin. I'm going to make this a 2-pinned arch rather than a pin here and a rotor here. So I'm going to select both of those, select restraint in all 3 directions and hit add restraint. Okay, that's the restraint scale is a little bit small for this scale of structure, so I'm just going to increase that. Now the next thing I want to do is, again, I want to, although this is a 3D structure, for a stable solution, I'm going to want to restrain it out of plane because I'm really only going to be interested in the in-plane behavior. So if I go into 1 on my number pad, it is structural behavior in this plane, right? So I want to restrain it out of this plane. In this case, I want to restrain it in the Y direction. Now the easiest thing to do, you know, it's probably a good exercise to run an analysis without doing this and you'll see what you get. You just get, you know, rubbish results. But if I come on to top view and I come on and box select all these guys, I now have all of these nodes selected and I want to apply a restraint in the Y direction to all of these. So I can just go on and hit add restraint, and now we've restrained it out of plane. So hitting that guy hides those. We can tab out of our edit mode. We can hide our restraints panel, come down to applied forces. I'm just going to apply self weight in this case. I'm going to collapse that down. I won't export the model, come straight down to analysis and just hit analyze structure and we're done. So we can come on down again and do all the same things we could do before. So I'm going to bring that back to 1 for starters and turn on my deflected shape and then start scaling it up so you can see the deflected shape for the structure. We'll go back into 1 front view mode. Now we will turn off our wireframe. Let's turn on our axial force heat map. So let's do it via the pie menu this time. So Alt or Option and W, and let's turn on visualize forces, and we can see a force, the force heat map essentially. Let's change the map again. We can do that via the pie menu. Instead of red blue binary, let's go with jet continuous. And again, we get a visual representation of the axial forces. And if we wanted to know the actual numbers, we could come on in and we could turn on our labels. So let's go with member force results. And again, we can zoom in and see what the forces are in each of our members. All right, so that's structure number 2 dealt with. Let's get on to the third one. So I'm going to clear that guy. I'm going to hide the 3D truss structure model. I'm going to come on down to our next one, which was the simple 3D truss. Okay, so here we go. This guy, again, we can quickly add materials and sections in the exact same way that we've seen in the last 2 examples. Now, restraints. In this case, I want that guy to be fully restrained. So I'll hit add restraint. I'm just going to reduce the scale, let's go at 0.5. Okay. Now, with this one, I am happy for this I want full 3D behavior essentially for this structure. I'm happy it has enough stiffness in the Y direction that I'm not going to get essentially rubbish results by applying forces in the Y direction. So I have a full pin here. This guy and this guy I want to restrain in the Z direction. I want to restrain it in the Y direction but not the X direction because I want those to behave like a roller. So I will add restraint, that's fine. And then this guy down here, I just want to be restrained in the Z direction, so I don't need it restrained in the Y direction. So I'll hit add restraint. In fact, I will restrain it in the Y direction. Okay, so this is a good example of how would you modify a restraint after you've added a restraint, right? So this guy down here, I want to modify, right? So the way to do this is actually come in here and identify the appropriate restraint in here and change it manually, right? So the first thing I need to do is know, well, what node number is that? Well, that's easy to work out. We can just come in here and turn on our node numbers, and we can see that that's node 26. Okay, we'll turn those off again. So I can come down to the restraint for node 26 and I can manually change the restraint in here. So I want to add restraint in the Y direction, so I'll just flip that from being a 0 to a 1, and we can see we now have our restraint in the Y direction. Okay, excellent. So we'll collapse that guy down. Let's just apply some forces here in the Z direction. Let's go with minus, let me see, minus 10 kilonewtons, and let's just put that onto, let's go into front view mode. I'll add it to, let's just say that guy and that guy, it doesn't really matter. So we'll add force. And let's put an out of plane force on this as well. So let's come in here and here, again, kind of arbitrary locations. We don't want anything in the Z direction this time, but we want it in the Y direction. So we'll say, let's go with 10,000, no, let's go with 15,000. So 15 kilonewtons, add force. Okay, great. So with that done, we'll come on down and just hit analyze structure. Again, out of edit mode into object mode, hit analyze structure, and we're done. Now we have our force labels turned on from the last time, so let's turn those off. So now what I want to do is very briefly, just as a sense check, look at the deflected shape. Very often this is the quickest way to work out whether you have some sensible results or not. So is this, qualitatively speaking, doing what I expect it to do? In that plane it is. If I look in the top down, it is as well. Okay, so that gives me an initial degree of comfort that this was a valid analysis. All right, done. Let's move on to the last structure. So let's just in fact wipe that structure out. We will turn it off in the 3D view. Come on down. Let's just hide that panel. Come on down here and select the last guy. If you've seen any of my videos where I've been sort of devlog videos of building this add-on, you'll have seen this structure already several times probably. So very quickly, the only thing, in fact, this is probably one of the simplest structures to do because to model, because the restraints are the same. It's just 4 points of restraint, and it's full X, Y, and Z restraint on each one of those nodes. So I'm going to super quickly run through this one, right? So in edit mode, I'm going to come in and just assign steel to everything. I'll assign section 1 to everything. Restraints, actually the easiest of all of them. So it's just restraint here, 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 and here. We'll add those restraints and come on down. Applied forces, we'll just leave it at self weight for now. So although this is not 0, there's a number in there from the last time we created a force. It's what's in this list is what's actually applied, including self weight or not, depending on whether this box is ticked. So there's no other forces applied except self weight. All right, that's fine. And yeah, let's just go into object mode, analyze the model, and we're done. Okay, so we'll scroll on down here, and in fact, yeah, we won't even have to look at that. So let's just collapse that panel, and we'll just look at our deflection. So I'm using my pie menu this time to look at my deflected shape. Okay, and straight away we get a nice picture. Obviously, massively scaled up, scaled by a factor of 200, and we can change that scale or slide that scale back and forth again to get that qualitative feel of what's happening. So that about wraps us up for our basic usage of StructureWorks. So if you have any questions, bug reports, or unexpected behavior that you want to flag up, or suggestions for features for future releases of the StructureWorks add-on, head over to the forum, the community forum on EngineeringSkills, or you can go to the StructureWorks page and you'll see the forum linked at the bottom of that page, and leave any comments or thoughts over there, and I'll be sure to get back to you as quickly as I can. Okay, so I hope you find it useful, and yeah, I'll see you in another video very, very soon.